Namaste, welcome to my class. Today I have brought here the questions from trigonometry. Okay, those who have started the basic level, okay, in trigonometry, it will be very helpful for them. Okay, and now look here. First question to prove is here number one. Number one, okay. I'm doing number one solution here. First of all, we have to write here left hand side. Left hand side is given there tan alpha, this is the symbol of alpha, okay, into cot alpha. As we know that we have to bring 1 here, that means we have to cancel this. And we know tan alpha quotient relation is there, we have found it already, sin alpha by cos alpha, okay. Its quotient relation is this, okay, that I have shown in previous classes. And cot alpha means we have its quotient relation, next is quotient relation is cos alpha by sin alpha. Here is multiply sin. Then look here is cos alpha, here is cos alpha, we can cancel 1, okay. And sin alpha also cancel it by 1, okay. And now here came here 1 into 1, okay. 1 multiplied by 1, we have here 1. This is our right hand side, okay. Then it is proved. Now let's move to the question number 2. In question number 2, there is given, look children, left hand side is given there sec theta, this is symbol theta, by cosec theta, and we need to bring here tan theta. That's why, look here, what you have to do in reciprocal relation, we know sec theta means 1 by cos theta, and whole upon cosec theta means in reciprocal relation we have found that cosec theta means 1 by sin theta. Look here children, now look, this fraction is divided by this fraction, then we can write it like this, okay. 1 by cos theta into, this will be reciprocal one, sin theta will go up, we are changing divide into multiply, sin theta off, then by 1, okay. Then look here, what came here, now see, here came off sin theta by down is here cos theta. We know, okay, just now we had open here only, look here, sin theta by cos theta was the formula of tan theta. That's why we can write in place of this tan theta. This is our right hand side, okay. Then proved. Our right hand side is tan theta, it's proved. Okay, similarly look here, how to prove question number 3. 3 number, look here. First of all, write here left hand side. Here in 3 number there is given sin A plus 2 cos A, its whole upon there is given sin square A plus 2 sin A into cos A. And for this question, look here, how to solve this question. First of all, here is 2 term, okay. Here are 2 terms given, then write here same. There is no common, that's why it's same. They are not like term also, we can add them. If they are like, then we can add. But look here, here sin square A is 2 sin A cos A. Here is also 1 sin A, here is also sin A, okay. Then we can take it common. Sin A take common. There was sin A into sin A because sin square A was there. 1 sin A is remaining now. Now here is left 2 cos A, okay, because sin A we have taken common, look here. Here is left sin A plus 2 cos A in the bracket, here is also up in numerator, okay, sin A plus 2 cos A. That's why we can cancel this and this. here is cancel 1 remaining, and here is 1 by sine A left here, and we know 1 by sine A means this is reciprocal relation. This is cosec A. This is our right hand side. Okay, 1 by sine A means cosec A. It is okay. Then our we solve left hand side and we got here right hand side. Cosec A. It is proved. Okay. Now let's see here question number 4. Okay. In this question number 4, what is asked to prove? Look here. Here is asked question number 4. Here is given sec square A minus cosec square A, and we have to bring here tan square A and cot square A. We have the formula here. Sec square A means 1 plus tan square A. Sec square in tan, there is only one formula. Sec square A means 1 plus tan square A. This is in Pythagoras relation. Okay. And we know cosec square A. Okay. Cosec square A means what? Look here. In formula in Pythagoras relation we had upon cosec square, okay, A minus cot square A equals to 1. Okay. We had upon this formula. And when you bring this cot that side, okay, what will come here now? Then 1 plus cot square A. Okay. In Pythagoras relation, then remove the bracket now. 1 plus tan square A minus 1 minus plus, it will be minus here. Okay. And right here cot square A, and this minus 1 and plus 1 cancel. And what is remaining now here? Here is remaining tan square A minus cot square A. This is our right hand side to bring. Okay. RHS hence proved. Okay. We proved the right hand side from this. Okay. Because in sec, from sec we can bring tan, that's why we open this 1 plus tan square A, and cosec square means we can open in cot, that is Pythagoras relation 1 plus cot square A. And when you remove this bracket, this minus will multiply here also and minus will multiply here also. Both will be negative, then minus 1 and plus 1 cancel, and tan square A minus cot square A is remaining there as our right hand side. Okay. This is our solution of 4th number. Okay. Now let's see here 5 number. Okay. 5 number, what is to put there? In 5 number, look children, here is given cosec power 4A minus cosec square alpha. Look, we need to bring cot power 4 alpha plus cot square alpha. That means we have to open this like this. Okay. Can you make it square? Because power 4 means this 2 multiply. Okay, 2 to the 4. That's why we can make here. Here is the same. Okay. Cosec square alpha. Then look, here is cosec square alpha. Here is also cosec square alpha. We can take it common. Cosec square alpha. Okay. Here must be AA. Okay. And alpha. This symbol must be same. Okay. Here must be same. Okay. Alpha here, all are alpha. Okay. Then make here also alpha. Okay. Then cosec square alpha is common. If you take common cosec square alpha, then 1 cosec square alpha is left here. Cosec square alpha is left here. And minus 1. Because cosec square alpha was here. Okay. Here is C left. Cosec square alpha. Common taken, then 1 remain there. And look at here now. We have to bring answer in cot. That's why we need to remember that there is only one relation, that is cosec square alpha can be brought into cot. There is only one, that is cosec square alpha minus cot square alpha equals to 1. It was in Pythagoras relation, okay? Now look here, when you find cosec square alpha, then what will happen here? This will go this side and right hand side will be plus, okay? Then it will be here 1 plus cot square alpha, okay? Like this. And we know when you take this one this side and cot this side, then it will be cosec square, okay? Alpha minus 1, okay? Cosec square alpha minus 1 equals to, here will be cot square alpha. From this formula only we have derived, okay? Then when you multiply this inside, it will be 1 into cot square alpha plus this multiply with this, it will be cot power 4 alpha, okay? Like this we can add this power 4 first, cot power 4 alpha plus cot square alpha. This is our right hand side to prove, okay? Then we have right here proved. We open the formula of this left hand side and we got here right hand side cot power 4 alpha and cot square alpha, cot power 4 alpha and cot square alpha. We have one formula there, okay? Only one formula, that cosec can be brought into, okay, cot, that is in Pythagoras relation, cosec square alpha minus cot square alpha equals to 1. From this we can derive this, okay? Like this we have to solve these questions, okay, to prove. I hope it will be very, very helpful for you, okay? Similarly, now question number 6, look at it. 6 number solution right here, okay? And here is given, look, tan square minus sin square, okay? Here is given left hand side right here, okay? Tan square a minus sin square a right here. And look here is the product. Here is the product and here is the minus, okay? We have to bring this product one from minus 1, okay? For that, what you have to do, look here. As we know, tan square a means sin square a by cos square a minus sin square a, okay? This nothing below this 1 means there is 1, okay, in denominator. Now take here LCM, okay? Cos square a right here, this multiplies here, it will be here, because here is denominator cos square a, that's why here will be sin square a minus, it will be here now sin square a into cos square a, okay? Like this we have to write by taking the LCM, okay children? After taking this LCM, look, we have to check that there are two terms. Look, here is sin square a, here is sin square a. Now we have to take here sin square a common, okay? Sin square a common, take, then here is remaining 1 and here is remaining cos square a, and down there is cos square a. Now let's write here, and here we can write sin square by cos square separately, sin square a, okay, by cos square a, and inside the bracket there is 1 minus cos square a, and we know that sin square a by cos square a means tan square a into, here is 1 minus cos square. In Pythagoras relation it was 1 minus cos square a means it was sin square a, okay? And our question was asking to find, okay, tan square a into sin square a we got, okay? That is our right hand side and our question solution is proved, okay? Like this we have to prove it, right? Now let's go to question number 7, okay? How to solve question number 7 I want to show you here. Here write 7 number, okay? And here left hand side, okay? And look here children, here the left hand side is given there, a cos a plus b sine a square plus a sine a minus b cos a square. Okay, it is in the formula of a plus b whole square, and it is the formula of a minus b whole square. That's why now let's open the formula. That is a square plus, okay, plus 2ab. That's why 2 into a means here cos a, into b means there b sine a, okay, and plus b square means there b sine a whole square. Okay, children. And similarly here a minus b whole square means, first of all, right here a square minus 2ab. A means there a sine a into b means there b cos a. Okay, and plus this b square means there b cos a whole square. Now let's remove this bracket. What comes here? Look here. It will be a square cos square a plus, let's multiply this one, 2ab will be same. Okay, here will be here sine a cos a plus, upon this then it will be here b square sine square a. Okay, here also open the bracket, here will be here a square sine square a, and minus there is 2ab sine a cos a. Okay, sine a cos a plus here will be b square cos square a. Okay, here will be b square. Okay, like this we have to write here first. Now check there, is there any like term to cancel? Check there. Yes, here is plus 2ab sine a cos a. Okay, plus 2ab sine a cos a. Here is minus 2ab sine a cos a. We can cancel it. And after that, see here. Here is a square cos square a. Okay, here is us, okay, b square cos square. That means we can take here cos square a common. Okay, if we take cos square common, here is remaining, okay, a square plus b square, and then next one look at b square sine square a, and here is sine square a. You can take sine square a common there, sine square a common take. Then what will remain there? Here will remain also b square plus a square. Okay, now after this what to do? Look here. After that, say children, a square plus b square, a square plus b square is common. You can take here. Now I am doing it this side. Okay, we can take here a square plus b square common. Okay, a square plus b square, a square plus b square common. And what is left there? Children, left one is put in bracket, and the bracket here is cos square a plus sine square a. Okay, and we know that so cos square a plus sine square means 1. Then here is remaining here a square plus b square into 1. It means we got here a square plus b square. Okay, here is, okay, it was minus here. Okay, this is a square plus b square. It is our right hand side. Okay, right hand side. Okay, then proved. Okay, we have to open here a plus b whole square formula, a square plus 2ab plus b square. Similarly here a minus b whole square, then a square minus 2ab plus b square. Then we have to open here this one, a square cos square a plus 2ab sine a cos a plus b square sine square a, plus here also open a square sine square a, and here is minus, okay, 2ab sine a cos a plus b square cos square a. Then 2ab sine a cos a, 2ab sine a cos a cancel. Then here is b, look here, cos square a common. Then it is left here a square plus b square. Here is sine square a, and here also sine square a common. Then b square plus a square left. Here a square plus b square is common. Then here is left in bracket cos square a plus sine square a. As we know that cos square a plus sine square plus cos square a means 1. Then a square plus b square into 1 means a square plus b square. That is our right hand side to bring. Okay, like this we have to solve it. Okay, children. Okay, now for question number 8. Question number 8. Okay, left hand side is given there. Look, children, 1 by cosec theta minus cot theta. Okay, because our aim is to bring here cosec theta plus cot theta. Okay, and we know that in cosec and cot there is one formula in Pythagoras relation, that is, you can write here cosec square theta minus cot square theta equals to 1, and down we can write here cosec theta minus cot theta. Okay, now remove this formula 1, a plus b, a minus b, 1 a square minus b square, that is cosec theta plus cot theta, and the one is cosec theta minus cot theta. Okay, and down it will be there cosec theta minus cot theta, same, and this cancel, and our remaining one is the result to bring. Okay, that is cosec theta minus cancel, then plus remaining cot theta. Okay, that is our result to bring. Okay, this is our right hand side, then we have right here proved. Okay, like this we have to prove this question number 8. Now let's move to the question number 9. Okay, for question number 9, what to do? Look here, Salim. This 9 number is here. Okay, and probably in this 8 number, and 9 number, how to solve it? Look here, 9 number is given there left hand side. Okay, 1 by 1 plus cos a plus 1 by 1 minus cos a. Okay, then when we simplify it, first of all we have to take its LCM. Okay, take LCM, that is 1 plus cos a, both are different denominator, then multiply them, 1 minus cos a. As you know that here is the denominator 1 plus cos a, this will divide with this LCM, then this and this cancel, and what is remaining here? 1 minus cos a will multiply with 1 minus cos a right here, plus, now here is the denominator 1 minus cos a, 1 minus cos a, 1 minus will cancel, and this 1 plus cos a will multiply with 1 into 1 plus cos a. Okay, now let's remove this bracket, 1 minus cos a plus 1 plus cos a, this plus cos a minus cos a cancel, 0. Then here is, we know a plus b, a minus b, which formula here? A square minus b square. Okay, this formula is a square minus b square. Then up there is remaining 1 plus 1, there is 2, and down there is 1 minus cos square a remaining. Now here is 2 only. Okay, and down there is 1 minus cos square a. 1 minus cos square a means in Pythagoras formula we have sine square a. Okay, 1 minus cos square a means sine square a, and we can write this 2 into 1 by sine square a. That means in reciprocal relation we have learned that 1 by sine means it was cosec, there is 1 minus 1 by sine square a, then it will be here cosec square a. Okay, 1 by sine means it was cosec a, but if here is square, here will be also square. Okay, if here is cube, here will be also cube. According to this power, here will be also the power. Okay, 1 by sine square a, that's why it will be here cosec square a. It is our right hand side to right hand side, then we have tried here proved. Okay, this question number 9 also proved. Okay, now let's move to question number 10. Okay, for question number 10, look here, what to do. See here. This 9 number also we have already proved. Okay, 9 number also we proved. 8 number also we proved here. Look for 10 number. 10 number is asking to prove there square root 1 minus sin A by 1 plus sin A equals to sec A minus tan A. This is 10 number. Okay. Now look here, children. What to do in this question? Write here left hand side and write here square root 1 minus sin A by 1 plus sin A. Okay. Then look here, 1 minus sin A by 1 plus sin A. Then we can multiply up and down. We can multiply up and down by this opposite sign. Look here, it's 1 plus sin A, then we can take it minus sin A. 1 minus sin A by 1 minus sin A. Why we are opening? Do you know? Because when you multiply this 1 plus sin A, 1 minus sin A, it will be in A square minus B square. That's why it will be now here up. Here is 1 minus sin A, 1 minus sin A, same became 1 minus sin A whole square. It will be, and down it will be here A square minus B square. A plus B, A minus B. That will be here A square minus B square. B means here sin A. Okay, 1 minus sin square A. Now what to do here, children? Look, you can write the same 1 minus sin A whole square, and we have its formula also now. 1 minus sin square A means we have cos square A in Pythagoras relation. Okay, that I have explained in previous class. Then both of them have square. Then we can write like this. Look here, whole bracket 1 minus sin A by cos A whole square, because here is also square, here is also square. Then we can put them in bracket and write whole square. And after that, what to do? Look here, children. Now this square and square root will be cancelled, and here is remaining 1 minus sin A. Down is there cos A. Okay, square root cancel with square here. Then here is single denominator. Here is single denominator. Okay. Of there. Then in place of that, in such case, we have to separate this one. This is 1 by cos A, and this side it will be here sin A by cos A. Okay. 1 also upon cos A minus sin A by cos. If we take LCM, then again it will become same. Okay. Now we know in reciprocal relation there was 1 by cos means it was sec A, and cosine relation it was sin A by cos A means it was tan A. Okay. This is our right hand side to prove, no? That's why our right hand side came here, right hand side equals to RHS, then right here proved. From left hand side, when there is a square root, we should try to cancel this square root symbol. That means we took its opposite sign one here. Look at up and down, we can multiply by the same one. Here also 1 minus sin A, here is also 1 minus sin A. We can multiply up and down by same. Okay, and after that, here is the main thing. Here is single denominator. Then 1 by cos A minus sin A by cos A. We separate like this. And 1 by cos A means sec A, and sin A by cos A means tan A. Like this we got here right hand side. Okay, like this we have to prove this question. Okay. Now let's solve 11 number. The 11 number is asking us look children, 11 number is asking us here, I'm writing here once 1 minus sine power 4 alpha, okay, by cos power 4 alpha equals to 1 plus 2 tan square alpha, okay. Let's see here how to solve this type of question, okay. When there is single denominator, look here, first of all right here left hand side, okay, 1 minus sine power 4 alpha by cos power 4 alpha. First of all write like this left hand side, okay. Here is numerator 1 minus sine power 4 alpha, denominator cos power 4 alpha, right? And here is single denominator, that's why in such case we have to separate like this, look here, 1 by cos power 4 alpha minus sine power 4 alpha by cos power 4 alpha, like this separate the terms, okay. And now as we know that 1 by cos means sec power 4 alpha, it is 4, that's why here is 4, and here is sine power 4 alpha by cos power 4 alpha means tan power 4 alpha, okay. And now we have to convert this into square, sec square alpha whole square minus tan square alpha whole square, like this we have to make in the form of a square minus b square. As we know that it is, this is a and this is b, then it will be here a plus b, b means what there, tan square alpha, and a, that means sec square alpha minus tan square alpha. As we know that this means 1 in Pythagoras relation, okay. This will be what, sec square alpha plus tan square alpha into 1, its value is 1. Then now look here, we need to bring both in tan, that's why I write this one, sec square alpha plus tan square alpha, it means 1 here. Then what will be here now, sec square alpha means we know 1 plus tan square alpha, and plus it is right here tan square alpha only, okay. And we know that 1 plus this one is 1 only here, these two are like term, then tan square alpha plus tan square alpha we have to write 2 tan square alpha, okay. Okay, tan square alpha plus tan square alpha, 2 tan square alpha, and this is our right hand side to bring, okay, RHS, then right here proved, okay. Our question was 1 minus sine power 4 alpha by cos power 4 alpha equals to 1 plus 2 tan square alpha, that we solved left hand side and we got here right hand side. This is the solution for this question. Thank you very much. Please keep practicing mathematics, okay. If you have any question you can ask in comment box, okay. Thank you.